Good morning all of you, and let's take some good problems of probability and moreover relevant for upcoming JEE advanced examination. And the first problem, as you can see on the thumbnail, was let x be the set of all possible vectors ai plus bj plus ck such that abc belongs to set -1, 0, 1. And let's consider y is a set of all ordered triplet of vector b1, b2, b3 such that this b1, b2 and b3 belongs to set x and b1, b2 and b3 are mutually perpendicular unit vectors. Then you have to find number of elements in set Y. Okay, so how we can solve this problem? Let's start first understanding this. We know clearly set X contains, since A will have 3 choice, B is having 3 choice and C is having 3 choice. So set S contains in total 27 possible vectors. So if I see order triplet of ABC, it can be 1, 1, 1, 1, 0, 0, minus 1, 1, 1, 0, 0, 0, and so on and so forth. So this is what number of vectors that is set A fundamentally contains. Right, but set Y is all those vectors which is coming from set X such that they are mutually perpendicular unit vectors. Now it is worth to know that the only possible unit vector in set X is plus minus I, plus minus j, and plus minus k. So we have only 8 vectors out of 27 which are unit, because if I consider any combination of plus 1 with minus 1, let's say I minus j or I plus k or minus I plus k and so on and so forth, clearly their magnitude is not 1. So this is root 2, this magnitude is root 2, this is root 2, so clearly root 2 is not 1. So in that sense, the only possible vectors which is coming as a unit will be 3 choice, plus minus I, plus minus j, and plus minus k. Now we need them to be mutually orthogonal, like mutually perpendicular. So one of the possible combination is ijk, other can be, let's say, minus I, j, minus k, and so on and so forth. Now clearly since they are ordered pair, so if 3 vectors are mutually perpendicular, here I have 2 choice of putting plus minus I, again I have 2 choice of keeping plus minus j and 2 choice of keeping plus minus k. So in total I am having 8 choice, but in every 8 choice again I have 3 factorial choice. Suppose if I selected ijk, now since ijk must be ordered pair b1, b2, b3, so I can make ikj, that is different ordered pair 1, 2, 3 of vectors. Similarly I can do kij and so on and so forth. So 8 is total number of selection, and out of every selection there is 3 factorial ways. Hence the answer to this problem is 48. Problem can also be posed in probability. Let's say I ask if the vectors b1, b2, b3 is randomly selected from set X, what is the chance like these vectors are mutually perpendicular unit vectors. Now clearly b1 how many choice will have? So since there are 27 vectors in X, because A is having like 3 choice, B is having 3 choice, C is having 3 choice. So out of this 27 vectors, so v1 will have 27 choice, b2 is having 26 choice, and b3 is having 25 choice. Okay, so these choices we are having for all of them, and clearly there is no need to multiply with 3 factorial because it already takes care of all the ordered combinations. So I hope it is clear. So in that sense probability will be 48 by this. It would have been probability question. Let's try another question, and similar problem already came in advance, and the question is what is the probability that the 3 randomly chosen elements x, y, z, let's say x, y, z are 3 randomly chosen elements from the set 1, 2 till 10 what is the probability that their sum is 5? So this is easier one, because probability of sum is 5 is the number of ways in which sum can be 5 divided by total number of ways. So total number of ways in sample space. Now as you can see, x is having 10 choice, so is y and z. So total number of elements in sample space is 10 cube, and the number of ways in which you can add 5 is, we can use a star bar technique, because minimum value of x is 1, minimum y is 1, and minimum z is 1. So I can give 1 to all of them, so we'll have a new x plus y plus z is basically, now this would add to be 2, so that x, y, z is greater than or equal to 0. And from a star bar technique, or even you can count the solution, this is 2 plus 3 minus 1c, 3 minus 1. So actually it's 4 c2, which is 6, right? So the answer is 6 by 10 cube, which goes to 3 by 10 square. So just 300. So this was an easier question, and of course, like, we can give many questions like this. Part B can be number of ways in which x plus y plus z is less than or equal to 10. So how to solve? Again, you can see, since x, y, z is already natural number, so it's same as x plus y plus z is less than or equal to 7, because I can make a new variable x equals u plus 1, y equals b plus 1, and z equals w plus 1, such that u b w is now greater than or equal to 0, because if u is 0, automatically x is 1. So the new question gets converted to u plus b plus w is less than or equal to 7, such that u b w is non-negative. Now again, one way of doing this is, I can make u plus b plus w 7, or u plus b plus w is 6, or 5, 3, u plus b plus w is 1, and so on, and u plus b plus w is 0. Because you can see this 0 is possible with 0, 0, 0, and that will automatically decode to a solution of x, y, z as 1, 1, 1. Similarly, 1, 0, 0 will decode to 2, 1, 1, and so on, so okay. So you can find number of solutions over here with non-negative solutions at 7 plus 2, 9c2, then we'll have 8c2, and we have 7c2, and so on and so forth. Then we have 1. In fact, you can add this either with NCR plus NCR minus 1 is n plus 1 CR with this identity, or you can use simply binomial coefficient, because it's nothing but coefficient of x square in 1 plus x to the power 9. Similarly, is coefficient of x square in 1 plus x to the power 8, and this GP you can add and find the answer. Okay, so that is left hand exercise for you. I'll give you a more smart solution for this counting. Since u plus b plus w is less than or equal to 7, so I know this will be equal to this plus something, let's say alpha, will be equal to 7. Now when alpha equals 0, it will give this case. If alpha equals 1, I'll get u plus b plus w is 6, alpha equals 2 will give 5, and alpha equal to 7 will give last case. So now in fact we have a new problem, u, b, w, and alpha also can go from 0 to 7. And now number of non-negative integral solution is very easy. So it's basically 7 plus 4 minus 1 c 4 minus 1, which goes to 10 c 3. Now in fact, if you calculate this either by GP or by this stochastic identity or chain reaction I call, the answer to this problem is 10 c 3. So for this problem, the probability that you will be getting is 10 choose 3 divided by 10 cube. So that would have been a better question of doing probability. So I hope you have understood how we can integrate the problem of probability, and you can solve it in various possible ways, right? Let's try another question. Let's say third question. Again, basically probability can be mapped with so many other chapters, and let's see how we can map with the function. So suppose if there is a function defined from minus 1 to 1 to r, be a continuous function, let's consider a set or region S x comma y such that mod x is less than or equal to 1 and y is 0 to f of x. Okay. Now the question is, what is the probability that the area of region S? So now we select a set of functions I of x. Let's say psi of x is a set of function pi to the power x, psi pi x, pi to the power x mod cos pi x, pi to the power x 1 plus mod 10 pi x by 10, and let's say pi to the power x by mod 2024x plus 1. So the question is, if a randomly selected function is chosen from psi of x, means this set of functions. So how many functions are there? 1, 2, 3, 4. What is the probability that the area of two of them will be same? So now clearly you can see. So that is the first part, and second part, what is the probability that two of them will have largest area? Now the answer for both of them will be 0. So let's see why. Because X is the set which contains the area bounded by the figure, these functions basically from -1 to 1 and 0 to f of x. So we have y equal to 0 and f of x. Clearly you can see all these f of x is positive. Okay. So if I'll see the first function sin pi x at 0, it's 0, at 1 is 0, so it will do roughly like this. Similarly at -1, something like this. So we'll have this area. Right. So the question is, what is the chance that area of them will, like two of them will give same area? So of course there is 0, because you can clearly see sin pi x and cos pi x, they are different function. Pi to the power x is already same in all four of them. So area wise, this is going to give list maximum area will come out of 1 plus 10 of pi x by 10. Anyway, this quantity is always more than 1. Rest all these quantities less than equals pi x, less than equals pi x. This is also, since denominator is more than 1, so it will be less than pi x. Okay. So the chance that area of one of them will be highest will be 1 by 4, because out of 4 randomly selected function, there is only one function thus which will give the maximum area. So cosmetically, questions can be designed here, which usually advanced will not like design question in a very cosmetic version, but they can connect this with function also. In the last lecture I have also shown, like you can throw a dice and they can ask what is the chance that the cubic equation gives a real and distinct solution of natural solutions, because till now they have already focused on quadratic, so maybe they can use basic calculus and incorporate cubic expression as well. Okay, so this is how you basically solve these kinds of questions when they are related to the other topics.